Hello all, welcome to Tech with SAS. In my previous videos, I have covered leader and follower pattern. And in this video, we will see the various challenges, errors or pitfalls, right, of this pattern. But I will not cover the basics of this pattern because I have already covered in my previous video. So I request if you're not aware about this pattern, please have a look into those videos. Okay. So let's jump into these cases which are important to understand in case we are trying to utilize this pattern in our applications, right? So case one. So as we know that when systems are distributed or we use clusters, right? So in clusters, we have multiple servers, right? So here you can see in this example, we have five servers, server 1, 2, 3, 4, and 5, and there is also one leader server. Okay, so that become leader for all these servers, right? It gives instructions like replicas and all those stuff, right? So now if everything is good, right, so system is processing and there's no issue. But we also know, right, about this heartbeat, right? So we have to also verify whether server is still up or not, because might be that some server has gone down. So periodically we do heartbeat check. So in that server has to respond back, okay, yeah, I'm alive. Okay. So in case suppose there is some issue happens with a leader server, maybe intermittent, like some kind of a network failure, like for 2 seconds, or maybe some error, right? So, but whenever at that time you are doing a heartbeat check, there's a response from the leader server. So now the cluster will assume that leader server has gone down, right? So, but to function this cluster environment, we require a leader, right? So assuming that because heartbeat response was not positive from the leader server, they assume that the server has gone down, right? So now cluster will elect a new leader, right? So for example, they select, suppose this leader server has gone down in the heartbeat, right? Maybe in for short time, then cluster will select a new leader, right? So suppose server 4 become a leader server. So now all the all the task or whatever the requirement are being fulfilled by server 4 as a leader, right? Of this cluster. But because I said that whatever the issue was with the previous leader server, it was just for a few moments, right? So it might back up very soon. Okay. So now in this cluster environment, we can see that we have two leaders, right? So that can give a very problematic situation, because now other servers are confused, right? Because they have a split brain. So because they rely on leader server for certain instructions, and there are two leaders at the same time. Okay, that situation we have to handle, right? So because I mean, there can't be two leaders in the cluster environment, right? Because in this leader follower pattern, we have to utilize just one leader at a time. So how do we solve the problem, right? So leader going back, going down, and cluster electing a new leader, then previous is coming back up, right? So in the situation is something like that. We have two leaders at the same time. So for that, to solve this situation, we use the generation clock. Okay, so it is nothing but what happens that for every leader selection, we assign some number sequentially. Okay, so for example, in this cluster, if suppose there were four leaders, like, right, in the whole process. Okay, so what we'll have, like for every leader, we have some kind of a number. Okay, so suppose leader 3 has gone down previously and we have selected a new leader, so new leader will get number 4. Okay, so whenever we are interacting with the server, it will provide that number 4. So that will basically clarify that in case there conflict, the servers will see, okay, what is the maximum number which is being sent, right? So whichever leader is having the maximum number in the instruction, they will follow that, and other leader will not be followed or discarded. Okay, so by these kind of a sequential generation clock, we can basically solve this problem. Okay, so this is like a first use case which wanted to see what happens and what we can how we can respond in these scenarios, right? So this is called a split brain situation. Okay, so now let's understand the second case. So in this case, right, I mean, it's the same case, but what is happening that the leader is not down, okay, but it is slow in responding to the heartbeat call. Okay, so now if some server is being pinged, okay, for heartbeat check, and it is not responding for a long time, okay, it might be the case that it has gone down, or it might be case that it is overloaded, or maybe there is some high traffic or congestion in the network itself, right? So, but whenever there are multiple attempts and heartbeat check is failure, maybe the server leader is up, but because of the heartbeat failure, the cluster assumes that okay, maybe leader has gone down. So now they will because they require leader, right? So they will select a new leader. Okay, so here also server 4 becomes a leader server, but as we know that this leader is not down. Okay, it was just not able to respond to a heartbeat check call, right? So now in situation is that we have both leaders in the cluster, right? And both are giving instructions to the all the servers. So how do we ensure that only the new leader is basically able to do all the work? So what we do, we use the fencing concept, right? So because all the access resources like storage, database, whatever resources we have, right? We revoke the access of the previous leader, right? So what we do, we do a ring fencing, right? So in resources, so that the previous leader cannot access it, right? So that even if it try to give instructions, assuming that it is still leader, but it cannot because it can't have access to those resources. Access is got revoked. Okay, so by fencing, we can make sure that the leader which backs up after some time, or maybe it was discarded because of being slow, right? While the heartbeat check was performed, we can basically discard it by using the fencing concept. Okay, so now in leader follower pattern, we have to utilize both the concept, right? Either the split brain concept. We also need to use the generational clock, okay, so that whatever the maximum number is is there of leader, that is deemed readable by other servers. And also, whenever the leader server, which was the previous one, backs up or comes up, right? We also make sure that we also do a fencing on resources, so that even if the previous leader comes up, it cannot issue the commands to the whole cluster, right? So by these two checks and balances, we can ensure that our pattern works properly. Otherwise, there might be confusion in case the leader server goes down for some time and backs up, or maybe it is not down but slow in responding, right? So these two scenarios are really critical in terms of this pattern. Okay, I hope it is clear. So that's it for this video. Thank you very much for watching. See you next time. Please leave comments or questions. Please subscribe as well. Thank you very much.